So hello everyone, welcome to the Open AGI Forum. We're live at GoSim AI Paris 2025. So today we are extremely honored to have Dr. Jenia Jitsev with us. So Jenia has just concluded his brilliant speech on the master stage this morning, and the content was truly profound. So before we begin, we would like to remind our audience to follow GoSim's official channels on X and YouTube to stay updated with the latest news and exclusive content from the conference. So Jenny, welcome and thank you for having our talk. So how are you feeling and what's the energy like for you here at the GoSim Air Paris 2025?
Yeah, I'm happy to see a lot of familiar faces. Hugging Face folks, of course, PyTorch community. Actually, yeah, Llama Factory that we use for fine-tuning experiments with our own project that deals with reasoning, traces data, open thoughts, and the models we brought out with our tight collaborators from Stanford and Berkeley, Open Thinker, 32B and 7B. So as you see that the community has very nice flow doing things that are mutually beneficial, and I hope we can find ways to improve the coordination even more. So obviously it's good to avoid double work and help each other, but this is always requiring some good organization and governance to unfold this.
I see. So I want to let you take a brief introduction, but I saw your list. There's different character with you, like JSC, Slap AI, and Lion, and ERIS. So for those less familiar, so could you briefly explain how these different roles and organization interconnect in your work?
Yeah. So the actual funding organization where we are based as researchers, so myself, Medi Chair Team Mariana Nijurina as core researchers at LAION, belongs to Helmholtz Association, which is a large science organization in Germany. And Helmholtz Association entertains a number of research facilities through Germany. So it's a bit similar, like Max Planck organization that also entertains institutes. So we have in Germany these two big organizations, Max Planck and Helmholtz, where Helmholtz has a bit more focus on dealing with somewhat expensive large installations, devices that require a lot of funds and people to be maintained, including supercomputers. So the institute we are sitting at that belongs to Helmholtz Association is Jülich Supercomputing Center close to Cologne in Germany. And this institute has a long tradition of hosting large machines, supercomputers, since 80s. This is where my research lab originated. We are still sitting there. So the funding comes from Helmholtz Association for our research, and then by this virtue from German state. It's a public research facility. So the other track is our non-profit research organization LAION, that was formally founded in Hamburg in 2021. But Hamburg is more like a decorative seat. We don't have like a centralized office in Hamburg. We are decentralized bunch of strong labs that work together on topics that we consider to be important to push forward. Mainly those are around open foundation models and datasets that are necessary for their creation. So LAION then is somewhat a creature that binds together labs that are affiliated to different research facilities. Let's say our lab sitting at Jülich Supercomputing Center, another strong lab by Ludwig Schmidt, who is sitting right now in Stanford, another lab at Tokyo Tech by Ryo Yokota, who is also a senior LAION researcher with his students, Taishi Nikamura. So LAION is in a way then a network of strong labs, and Our own institute is somewhat a hosting body. This is roughly the story.
I see. So let's journey back. What initially drew you towards to the world of neuroscience, particularly unsurprised, unsupervised learning in the visual cortex, long before the foundation models became a buzzword?
Yeah, so I was interested in learning as a somewhat even abstract process. It was for me puzzling what it takes to get any type of external information that is floating out there and somehow imprint it to another system. So how does it work that out there is sources of information that contain bits that might be important to capture. So how do you capture them? So what it takes? And I mean, brain was obviously one system that is doing it very well. So I became just interested in the neuroscience because of learning being already functional there. And was working along the lines of understanding how learning and plasticity in the neural circuits go together. And at some point, I saw that progress can be made better by making this even more abstract. So going to core machine learning, abstracting away from all the complexity that we have in biology, which might be related to information processing to some part, and to some part might be just be a body sustaining story that has not so much to do with information processing, and the complexity of it is very high. So you disentangling it will take actually quite some time, and I was not feeling capable enough to do it, so I chose a simpler story to understand learning in more abstract terms. And then turned out that in the same time it became also clear that some methods we were working on, so quite simple, we called it back then winner-take-all-like circuits, can be stacked together in layers and scaled up. So same way how other people observed, scaling up simple operations can lead to powerful systems that can learn. So I switched then quite seamlessly into the deep learning direction that was then emerging in exactly the time where I was wrapping up my own PhD studies and thinking a bit ahead what to do. So I still did some more biologically inclined research towards rewards based learning and processing, so reward-based learning in basal ganglia as a part of the brain network, dopamine modulated plasticity. And then in parallel I was looking more and more into somewhat classical computer vision related machine learning, and landed up then in Uli Supercomputing Center where the big machines were standing that were then exactly giving the right ground for the experiments on larger, simpler but large scale networks, and also larger data to feed them with. So, and then my transition to, say, the new emerging field of foundation models as artifacts from transferable learning. So this was always my interest. So what are the conditions to create learning that actually deserves this world, namely then transfers also to various other conditions and tasks. So the foundation models were the first artifacts that were showing how this goes. So and I've then become focused on that. So figuring out why foundation models are capable to do what we see, and what are the still big, open problems, weaknesses in what they are able to do in terms of generalization. Because we see that generalization is still not strong enough as we would like to have it.
I see. So your talk this morning contrasted machine learning pre-2012 is like poor generation and reliance on label data, with the breakthroughs in scalable and transferable learning since then. So from your perspective, what were the fundamental conceptual shifts that enable this transition to foundation models?
Yeah. So I guess one important thing that happened was that people realized that the dataset composition have a very dramatic influence on how successful and unsuccessful learning will go. I think before the data-centric part was quite neglected. People were thinking a lot about algorithms, what make a good algorithm. So one thing that happened was definitely that people realized you have to make dataset distribution very generic and put as little prior as possible into composing the datasets, so that web-scale dataset collection become a thing. So you said you just grab everything you can, and it will provide you the diversity without putting too much expectation. What is the good data? Because people are really bad in, it turns out people are really bad in estimating what is good or what is bad for learning with algorithms, or maybe for learning, well, for human learning, they still, I think, can estimate what good is. So, and the other thing is exactly a bit similar, I think, not maybe exactly, but similar. In the algorithmic side, people began to understand that scalability of an algorithm, its generosity is the main thing. So it's a bit in the same spirit of Beta Lesson by Richard Sutton, where the statement is that if you can make a procedure scalable in terms of the more compute, the better it becomes, this is the way to go. So you don't think about very clever problem-specific priors that you built in order to solve problem X, Y, Z, but you think about the most generic way how the learning can be driven on the most generic data, so any data format that you would throw in should be consumable. And this generic scalable algorithms would be then the base of a successful generalist transferable learning. So people understood that simplicity, but I mean simplicity is difficult. It's not like that the most simple thing would win, so the most scalable simple thing would win. So you have to enable the dataset scalability and algorithmic scalability at the same time. And you see that even some extent, multi-layer perceptron is a scalable system. It's simple, but if you derive scaling law for multi-layer perceptron, you see that it is not as scalable, for instance, as, let's say, a transformer-based architecture. So still simple architecture, but more scalable than the NLP. So you have to find this balance of being still simple, but scalable and generic. And that were the two key elements on the data set and algorithmic side that allowed us then to create the scalable procedures that are right now are already quite successful in transferable learning, right?
Yes. So in this Open AGI Forum channel, we have interviewed Richard Van Q, another co-founder of LAION. So he already talked about the original story of the LAION. So in his side, so we are wondering what is in your side? What is the original story of LAION?
Yeah, and importantly, will they match?
Yeah.
Imagine they don't match. Then we have a problem. Yeah. So yeah, I think this is a movie-like story indeed, and this is not a self-compliment. It's happened in such adventurous way that I still enjoy thinking about it. So different people who are core LAION members or researchers came to LAION for quite some from rather different motivations. So driven by rather same despair, because they saw these powerful artifacts models being built with capabilities that are very interesting to study, but it's impossible to study them because they're behind closed doors, you cannot reproduce. But so motivations were quite different. I think from our side, it really originated from a journal club that we had together at our institute. So myself, Mehdi Cherti was my colleague presenting a DALI paper.
Yeah.
By OpenAI, and we, of course, followed up the DALI 1. Back then, 2021, there were two papers coming out. I think actually both involving Alec Redford, so our eternal hero. The CLIP paper, the contrastive language image pre-training, and the DALI paper.
Yeah.
So, and both were very impacting for the field. And to some extent, CLIP even was open weights. They had this important artifacts released, but in overall it was not reproducible. Data set was not there. Of course, for DALI there was no model even, so CLIP was a bit more open in that sense. And during this journal club, we realized that it is very important to study this now as a core machine learning artifact, because this is what gives now transferable learning, and transferable learning is at the heart of machine learning as a field. So we need to understand why this works. And we started immediately to reach out, so to scan who are the people who are trying to reproduce it as an open source. So actually during the journal club, we just Googled and came up with some hits of people that already had, I think, a Discord server that was called DALI reproduction server. Maybe it was not yet there, but there was. You can find it online. There is a gosh, now I'm missing the name of an important person. Lucid Rains. Lucid Rain. The Phil Wong was having this very strong tradition of re-implementing everything that was an important artifact, and we found at his GitHub, related to DALI reproduction, a way to just put an issue and saying, look, we would like to do it. We see you have already code snippets that are somewhat functional, but we would like to do it now on the scale that is interesting enough to replicate the stronger models at the larger scale. And we have supercomputers here that would be giving enough compute to do so. And this thread, this is openly available to people to read up. I think Mehdi Cherti wrote the first entry there asking, okay, we are here a bunch of researchers who would offer compute and can do it together. This resulted in some pings by other people who were also sitting at Discord. And I'm really ashamed that I don't know all the nicknames, but I would be able to look it up. So one of the central people back then, Clay Mullis, I think, he was then on LAION 5B paper as well. His nickname I forgot. They were saying, okay, we do a Discord server which unites the people who have now the same aim to reproduce DALI, and we see who comes and who can help. So we, from the researcher perspective, just found the crowd with the same drive. And then people like Richard, people like Romain Beaumont from Paris, Google Paris. Yeah. Richard was back then, I think, in his own small company, also related to another IT company in Bucharest, I think. Christoph Schumann was a German high school teacher who was also kind of flashed by the progress in the field and wanted to make it possible that people actually can play with these models freely. So he was more on the data-centric part. He had the idea that, of course, without the data, nothing can happen. So it was clear for everyone you have to collect the data set. He had an idea, let's then connect some volunteers together to help out with data collection. So when you see there were like this different streams, we were more proficient on the training side. We knew how to handle supercomputer and distributed training of such models already. We did some preliminary work on other model types, so we could scale up to hundreds or thousands of GPUs. On the other hand, there was a data-centric crowd who were then beginning to gather the data. And then, very luckily, Ludwig Schmidt, who was already a very acknowledged researcher in the field, became aware of this effort, and he brought his incredibly strong people in. So from back then, University of Washington, LNAI. And they very, very conveniently already implemented OpenClip. They were doing experiments on smaller scales, showing interesting things there. But of course, everybody understood that if you would like to study interesting phenomena, you have to go much higher. And we had this shift from the previous DALI, let's produce DALI motivation to, okay, let's do the OpenClip because the code base is already there. People would like to study it, are there. Clip as a model type has also a bit better systemacy in benchmarking. So if you create a model, you can quite easily check whether you are as strong as some other. So like OpenAI Clip. You can measure the scores of OpenAI Clip model and compare on the same set of benchmarks that were open already back then with your own attempt. With DALL-E, so there were like different scores like FID. For generative modeling, it was much less possible to compare your efforts. So we decided to switch to CLIP as a representation learning track. Also something that can do image classification, retrieval, different downstream tasks, which DALL-E couldn't. You could you could generate impressive samples, but then further on you couldn't really adapt it as a model backbone for downstream tasks. So we switched to CLIP, Ludwig Schmidt being there, this crowd of volunteers collecting the data set there, supercomputer being there, came all together, and that really exploded. So that resulted in the release of both LAION 400M and 5B as large-scale image text data sets that were fully open and ready to go for pre-training. And the supercomputers and the time granted by Gauss Center of Supercomputing, which is a German-based organization that gives compute time for the researchers. They gave us enough compute, not really enough, but enough to get just enough to get these experiments done. And then from then on, OpenClip became a highly reused model type. So this was basically the maybe research outcome was truly important, but even more important was this hope moment. All of a sudden, people understood, yes, it is actually possible with somewhat strong research, affine people from the community to come together and gather up all the resources necessary to catch up with the strongest frontiers lab, like OpenAI. Because the models that we trained, if you evaluate them on the benchmarks, they were matching or even did beating on some downstream tasks the OpenAI artifacts. And that was very surprising. I think we hoped that we could reproduce some trend that, if you do it even better with more compute, but we were able to do it actually exactly as them or even better, plus providing the scaling laws that were not provided in the original study. And then you see that these models, it's also very interesting for me, still per month, the old OpenClip models like OpenClip B32, trained on 34 billion samples from LAION 2B, still downloaded 1 million times per month. So in total, so although it's 3 years ago, and these artifacts are still useful for the community, and you see if you do the work the right way, it will have this long lasting impact and also be useful for people for a long time. So it's not only a short-living thing. You can make sure that it lasts for a while.
So your presentation has highlighted a problem, as I just mentioned. So research on foundation models was only reproducible by a few large industry labs. So was this inaccessibility the main catalyst for LAION, or were there other scientific frustrations you aim to address?
Yeah, I guess, if you even just forget for a moment that this research is happening behind the closed doors, you just ask yourself as a machine learning researcher, so what does it take to study the important directions in the field? And then you simply arrive to the question, well, it takes to collect the data in an open way so that others can build, so also can execute the same experiments. It takes to open source also the training code. So it's actually more indeed a somewhat standard scientific approach to say if we need to study important phenomena in the field, and definitely transferable learning is one of the most important. Foundation models as artifacts, this has to be available for others so that we make progress simply faster and also in more validated manner so that you don't have strange claims that who knows, is it right or not? It takes a year to figure it out via rumors and anecdotes. The main catalysator for us, coming from a research side, was indeed just to enable this type of research. So I think other people who were coming more from industry affine side, they were indeed worried that only few monopoles will be able to touch these important building blocks, and then the rest of the industry will be kind of damned to wait for the next release from the one gigantic or few gigantic labs, and then just to rely on what is there, or even without really knowing how this procedure come to be that resulted in this artifact. So I think for them, people with a more industry affine attitude, it was more pressing to remove this power concentration from the industrial landscape, and I think that worked out. For the research people, it was indeed just a standard approach. We have to study something in a reproducible manner. Currently it's not reproducible, so let's make it somehow reproducible. I think we are very thankful for the closed labs. OpenAI, Google DeepMind, Meta, and so on, Anthropic, because they of course show important directions. And then for research, it's just as good as, if you get some hints, you just take them. But it has to be, at some point, we need to make sure that research is reproducible for the open academic community, and this is where we are putting a lot of effort into.
So LAION alongside user AI and big science as grassroots research communities. So have you ever think about the different life, different destiny if you choose to the closed lab, big closed lab, to training the big scale model? Because what is the unique about LAION's approach and contribution within the broader open source ecosystem? And if we open the LAION website, it says 100% non-profit, 1% free.
Yeah, I mean, I guess, again, so it is very good that there is a diversity in the landscape of research and development around these models. Also, closed labs contribute their very heavy share. And I think choosing this open source track for me is just very pragmatic, egoistic decision. So yeah, I'm totally open into getting a lot of funds and having a good income working in the closed labs. But then my long-term impression was that if you do the research in this more collaborative manner, you just get hands-on various strong people easily, and then their skills and so on. True. I mean, of course, OpenAI unites the strongest researchers in the world, as well as DeepSeek, QN, right? But then the trouble.
No challenge.
No, it's a different story, I think. So then, what might happen is that you are still in the frame of a commercial entity that has to be reporting to whoever did investment. So what is your next big profit? And the research becomes inevitably oriented towards outcomes which enable you to report to your investors properly. So that can be in basic research trouble. So you could ignore very interesting directions because you have pressing needs. I mean, I'm not sure OpenAI, of course, as a formal non-profit, were certainly able to get rid of some of this pressure, and they were writing red numbers for a while, doing the research that mattered for them. But also there, if you begin to line up with some large influential companies like Microsoft, you begin to feel pressure along different lines of research that you might feel are very valuable now to follow, but you can't because you have other pressures. So, and for me, again, the egoism here was that I thought some of the directions that one should go in the research are not so compatible with industrial track. If I would know the way how to make it more compatible, I would have absolutely no problem working even in a closed lab. I just see that open source have better ways to enable research along the important directions and also enable them in a more efficient way, so that maybe on short term with closed lab you can push harder, but I think on midterm, long term, actually the broader community that have strong people there will get better traction in doing the research more efficiently. So it's an efficiency question. Maybe I'm wrong though.
I see. Yeah. So your presentation actually dedicates significant attention to scaling laws. Actually, there's about 10 pages is talking about scaling laws.
Yeah.
So it shows the reproducible scaling laws with LAION for 400M and 2B and OpenClip. So what were the key challenges in achieving this reproducibility in practice, and what did it demonstrate about the power of open data and models?
Yeah, I think one very clear challenge was just indeed the data set composition. It is, yeah, there are so many troubles bound to it. I don't think we would be able to list it in the short time we have. Even just, so starting with all the pipelines required to go to common crawl, extract something that is worth putting together as a data set, as a metadata, then filtering this further to make sure that the data set quality stays somewhat reasonable. Then you have to go and actually download the images. This is also irritatingly a difficult part. Just to have this initial courage to collect something on that larger scale that might actually fail as a data set. So I think we had quite a big luck that the data that we gathered was not, so we actually had an expectation that we train on it and it will be like very average. So we will have a large gap. So it was a fortunate moment, but of course you saw the troubles. So then being open, people discovered in the data set illegal samples, and now the big advantage of open data, of course, this is transparent. Then you say, okay, now we fix it. We cooperated with Internet Watch Foundation and C3P from Canada, who provided us really large hash lists of all the bad data that they managed to gather from public internet. And to me, it was a revelation how much bad data is still on the public internet and is not removed by the responsible providers. It's a bit strange because, you know, they are commanded to do so, actually. And then using these hashes, we were able then to create an updated version of LAION. So you see, to make the scaling law reproducible, this data set part is a lot of work. And here we need, I think, to unite more people to help, because it's a single orga. It's not healthy to do it all alone. Okay, there are other things, of course. You need to have proficiency using supercomputers, designing the experiments that provide you the measurements that are good enough to put on your plot and begin to fit lines that make sense and have good accuracy in predicting what happens on the unseen scales. So this is just, okay, scientific expertise question that we also had to acquire a bit. Compute time itself, so resources necessary for this, you need to write grants to obtain them regularly. So this is also quite a tedious procedure. So the reproducibility costs quite a lot. And then I think, one important thing to do is that there should be an exchange in the community how to make these procedures a bit easier to execute. So common grants, writing common grants, sharing compute time then among knowledgeable people, helping a bit each other that these procedures are not killing you as a rather small non-profit, right? So there is like both a technical, organizational, and scientific challenge to make it reproducible. I hope we are learning now on all three to get better and better, so it's not so painful for all the participants to get yet another study of this kind out. So.
So you already mentioned a lot of time of the data sets. So the AIW, Alice in Wonderland. Alice in Wonderland study is the fascinating part of your talk today. And the co-author, you are the one of the co-author, and the author, Mariana, and the co-author, Murdis, came to the Gaussian AI Paris today, but so unfortunately we can't take an interview with them. So maybe you can find the street interview of them in the Gaussian Foundation channel. So before we talk about the AIW study, so who named it? Who named the Alice in Wonderland?
Oh yeah, that was indeed myself. So
really?
I think so. I was surprised by the results, and then to me it really seemed like strange, weird environment out of this model behavior to the simple questions that so Alice, Bob, you know, this kind of creatures that you also use in computer science related communication problem settings. Alice was a bit of a accidental thing happening from this direction, but then using the name Alice made this association quite easy, because this was weird for me to observe how strange the models behave on the simple tasks, although they claim really robust, strong generalization. And then I was also, visualizing this original illustration from the book, where Alice visiting, I think it's Alice behind the mirror, actually, the second. The Humpty Dumpty. So there's this egg person with very rabbit, important, very authoritative manner, and the girl reaching a bit the hand towards it, and then it kind of a bit shaking and crashing in the end. That created a good metaphor in my head. So although it's not, I also don't like the balloony titles in our field. Everything is a bit a metaphor. But there I couldn't really help, and we put it in the title this way. Yeah.
So for those audience that aren't familiar, the AIW study shows the SOTEM LMs exhibiting strong fluctuations on simple problem variation that don't change the core logic. So what was the aha moment for your team, for LAION, when you realized these models was struggling so fundamentally?
Yeah, so first indeed we were not ourselves aware of this, the core important aspect of variations in the fixed problem template. We just took, so I mean there is a history of different problems that were shown in the community anecdotically or not to break in models in some sense. So there was a related problem in 2023 ghosting around in internet, I think Sally and her brothers or something. So it was similar. It is somewhat different, but related. So we just would first testing conventionally fixed static problems. But we saw that already in this case, even strong frontier models, like back then, what was that? Yeah, GPT-4 was already out there. Yeah, GPT-4o, that they sometimes were having strangely low correct response rates. And then this is where we, I think we were first a bit randomly exploring what might be the problem formulation that is inducing this kind of breakdowns, and then realized that you don't really need to change the problem much, you just really change the numbers, and that is it. And that was then indeed the aha moment. So we saw that it's not really a particular specific characteristic of a problem that makes it break, but it's something more generic. So something is broken indeed in generalization capability, that for one fixed problem template that is also a simple problem template, if you fill it with whatever numbers that make sense, it will solve it in one case, and then you fill it with slightly different numbers, it will break down. So that was something that we still struggle to understand why it is so heavily affected. From then on, it was quite a straightforward path. So we just generated some more variations, had also different problem templates, again, taking a template with placeholder variables again, and then saw always the same consistent picture that none of the models, so the first time we saw that a model can actually be somewhat robust across such simple problems was with the rise of the newer generation of reasoning models like O1. So O1, O3, if you confront them with these simple problems, they seem to be, to a certain degree, fine. If you begin again to change now the problem structure towards a bit more difficult, but not dramatically difficult. So not, again, this claim of solving Olympiad or graduate level tasks cannot be sustained. So they collapse much earlier on much lower difficulty. And this you see also in the reasoning models. But before that, before the reasoning models were coming, you could take any strongest Anthropic Claude or GPT or whatever, Mistral and others, so DBRX from Cohere, Command R+, they were collapsing entirely. And the thing is that, of course, these companies on their web pages, all of them, not a single one specifically now isolated for this example, but all of them write, our models are there for helping you in serious real-world business cases to solve whatever problems. And if you see such breakdowns induced by very natural variations in simple problems, I think it's not about the specific structure of this Alice in Wonderland problem. You can imagine now any problem that you would like to solve.
Yeah.
And then you confront a model of your choice with this, you see it performs well, okay. And then you are kind of, developing trust that it will be the case. And then you just do some modification without really suspecting that it can break something, because you think it's natural modification of the same problem, and it will break without that you notice it. So this is especially dangerous for the cases where you don't yourself know how to deal with the problem. You just hope that the model will do it for you. For Alice, of course, it's easy to see the breakdown because you know the answer. For another problem where you don't know really the answer, the models will give you a response, and then it actually also backs it up in what we call confabulations, in this very confident manner, saying, yeah, I double-checked my solution. It's all good, especially these companies like DBRX and Cohere, but also Llama to some extent. They have this way of model responses that are putting in the user confidence that it's actually all good, but it's not good at all, and then you don't realize it. So this is for conventional learning, conventional large language models, definitely a trouble. With the new reasoning ones, we have to see. So we still see these strong fluctuations, but it's way better than the conventional LLM for sure. And we don't see these strange overconfident responses that much. So actually, if you see that the model is starting to struggle, the fluctuations come, it also says, oh wait, oh no, I'm not sure, this is tough. So there is a way better reflection, so in a sense, than calibration towards its own uncertainty. This is this makes us hopeful that reasoning models are actually a good way to go.
Yeah, because the AIW papers first come out last year. The reasoning model haven't exist, is it right? So there's two tests. Before the reasoning model and after the reasoning model, you go to the two tests. And when the first test we saw is like GPT-4 or Llama 3, it's all foundation model. But after the reasoning model come up, it take the Alice in Wonderland test, but it still have the struggling. It's really wondering. Yeah, so what's this remaining deficits tell us about the path forward?
Yeah, this is a very good question. It might be that a simple story here is that you can, to some extent, scale up the reasoning traces data, which we also now experiment with. So Open Thoughts as a data set that was first having 114K samples, now it has 1 million. It might be that you can really solve this by scaling up the reasoning traces data, and at some point you have a transition to a state where the robust generalization comes up, at least for some level of complexity of the problems. So if you take, I don't know, a DeepSeek R1, so starting from the base model, DeepSeek V3, and then putting on the top around, I don't know, 600, 800K reasoning samples, it might be just not enough to get full robust core reasoning installed. So if you just scale it up in straightforward manner, like it happened before with other learning procedures, because you see the clear improvement. You see it's getting better.
Yeah.
And if you do model distillation, sometimes it's enough to have just, so I think a work by S1, Stanford and Limo, I forgot the lab who was behind Limo, they took 800 or only 1,000 reasoning traces. And then you already see the jump. And the base model was QN32B.
Oh.
So conventional LLM. So you see that there is already a strong jump if you expose the model to some volume of reasoning traces, and then of course you might think, okay, what if I do it then, to the degree of 2 million, 5 million traces, and then at some point you have a transition, it's over, you solve it. But here you have to be, of course, careful, and this is possible now with open data like Open Thoughts or other efforts that the community is doing, OpenR1, by Hugging Face. You can look into the post-training data. This is a very favorable situation. You know that QN32B cannot solve Alice in Wonderland. You see it's really breaking hard. Yeah. So you're pretty sure that in pre-training, there was probably no leakage on that 2.5 model type. For 3, I don't know. And then you have the open post-training data, which you then apply. You can check whether there are similar problems like AW. If there are no, you don't have a leakage, and then the whole improvement is due to being exposed to generic reasoning traces. This is for S1 and Limo. We checked just for fun. There is no doubling there, so there is no leakage. And I think this one straightforward story has to be tested first before we try to think about more complicated solutions. There are a lot of ways how you can think that can be fixed, but scaling up reasoning data, which is now scalable because you can take reasoning models, and it seems to be that they are good enough to get synthetic reasoning trace data. You don't really need to dig so much for the real data, which you can also have. So let's try to do this first and figure out whether this is then enough to get these fluctuations disappear. Then we know it's all about data again.
Yeah. So that's cool. Let me really want to hold a panel with you, Marianne and Marty. Maybe next time in the next Ghosting AI. So finally, as Ghosting AI Paris 2025 continues, what are your hopes for the conference and the connection made here? And where do you want the Ghosting AI European to hold next year?
Oh yeah, well, got too many good questions. That requires some thinking. So I mean, I met
here, answer shortly. Yes.
I met here people from Eclipse Foundation, from Linux Foundation, which from Linux Foundation we had good contacts with. So here the hope is that we manage to put this more organizational frame to get even more potential from all the strong people rotating in the open source community. So I hope we stay now more on track with these organizations helping out each other. So this was very useful for us in Ghosting to meet all of them. So European side, what was us? I mean, Paris is actually the best place, I have to say. There's no
Germany?
in Germany struggles, so we have to be very fair about this. Germany has a broken landscape of both research and industry in machine learning. We have to fix it. France is doing much better, but I mean, LAION is there. Black Forest Labs is a big hope for Germany.
Black Forest.
Very strong people, very capable people, but we need in Germany to get the politics right so that these capable people are having good conditions. So I hope the people from politics. I think if you were to come to Germany, of course I'm very biased there, so Cologne would be a good big city, a joyful city, offering a lot of opportunities for people to walk around on the one hand, but on the other hand, a supercomputing center is close. Other people from Germany can come easily to Cologne because it's a very good connected hub. I mean, another obvious choice is Berlin, but honestly, Berlin scene in machine learning is kind of, dying out a bit, I don't know why, it's also for me a mystery, but I guess something like Cologne as a hub to meet would be a good thing to do, and many people I think would be able to come there because it's easily reachable. So it's also an interesting place to visit.
Okay. So thank you so much, Jenia, for your insight and inspiration today. We hope our audience has found it valuable. So for audience members who wish to learn more about your work or connect with you, what are the best channels to find you?
Yeah, we are of course a bit heavily Discord. Discord rotating. I mean, a lot of open source communities are living in Discord. Whatever the reason for that, it's kind of accidental. Coming to LAION Discord server, the very same name as my Discord ID, so you can ping me there anytime, and one can exchange. Email works.
Okay.
Yeah, even my official work email from Research Center Jülich is a good address to contact me. So LinkedIn I use actually not so much. So there a lot of stuff coming to LinkedIn is discovered after months. So maybe better to write an email.
Okay.
Or coming to a strong conference like NeurIPS, ICLEA, ICML, CVPR. We go there, we exchange there. So this is also a good opportunity to exchange.
Okay. So thank you, Jenia. So for our audience, please remember, don't contact to Jenia's LinkedIn. So please continue to follow GoSim official X and YouTube channels, as well as OpenAGI Forum for more exciting content and update. Thank you, Jenia.
Thank you so much.